Good day, guys. We are looking now at other problems of volumes in mathematics. So in this problem, we are told to make a neat sketch of the graphs of y equal to 6 plus x squared and y equal to 4 minus x squared. Then show the area bounded by the graphs, the y-axis, and the line x equal to 2. You see, when I read the equation of volume, those are the key things to pick out. Then show the strip that you use to calculate the volume when the area rotates about the x-axis. So those are the key things I pick out when I'm doing volumes. Now, we will start with the A part. We will have to sketch our graphs. So if I put down all the graphs I've mentioned, there is y equal to 6 plus x squared, there is y equal to 4 minus x squared, there is y-axis. Y-axis is a graph whose equation is x equal to 0, and there is x equal to 2. So whenever I've got 4 graphs, the first thing that comes to my mind is that 2 of the graphs are giving me the limit of intersection, especially when I'm not told to calculate limit. So it means I will be integrating from x equal to 0 to x equal to 2. And another thing that I pick out from here is that if I happen to be reading my limit from the x-axis, that tells me that my strip, my representative strip must touch the x-axis, which is obviously the vertical line. So those 2 graphs are simple graphs if you know their properties. So this is, the first one is a parabola with what we call a smiling face. Look like that, since our a is positive. Here you see a is positive, the coefficient of x squared is positive. Then this one is what we always refer to as a sad face, because the coefficient of a is negative. So negative means less than 0, positive means greater than 0. So once I'm sketching the graphs, that is all I do. So let's go to the xy plane and try to sketch our graphs. So if we go to the first one, this is y, that is x. So we already know the shape looks like that. So the next thing I will need to be interested in is where does the graph touch the y-axis. You go there, if you make x 0, you see that it touches the y-axis at 6. So let's say you choose to put your 6 somewhere there. It means our shape should be something like that, as you see. If I want to check where it touches the x-axis, you see if you make y 0, you'll be getting x squared plus 6 is equal to 0. And if you try to solve for x, you'll be getting x squared equal to negative 6. So x cannot be a real number, telling you that the graph does not touch the x-axis. So with this graph, I'm as good as done with this graph. So it should be something like this. So again, something of that nature. And this number here is 6. Now let's go to the next graph. Y equal to 4 minus x squared. We already know that if a is negative number, it has that shape which we like calling the surface. So now, what else do we need? We need the intersect. When x is 0, you see y will be 4. So since 6 was there, let's say we choose to put our 4 somewhere there. Then we expect our shape to be of that nature, then passing through 4. If you're interested in the x-axis, you make y 0. That is another thing that is important. If you make y 0, you get 4 minus x squared is equal to 0, which will show you that that graph touches the x-axis at plus negative 2. So if I sketch my graph, it should touch the x-axis at plus and negative 2. So I expect a shape that looks like that, where this is 2 and this is negative 2. Also, at times when you sketch parabolas, it's important to know where the turning point is, especially when times the graph can be like that. There is nothing that says the turning point must be here. So if I need a turning point, I can quickly calculate using the formula for axis of symmetry. In this equation, there is no b, so you see that there is no x, sorry, it means b will be 0. So if you get 0 over 2a, you get 0, and if your x is 0, and we substitute there. You see that y is 4, just reminding you that the turning point is at 4. If you do the same thing there, b also be 0 because there is no turn in x, and the turning point is exactly at 6. So I've sketched the first two graphs. I've sketched the y-axis already. I'm left with a graph x equal to 2. So x equal to 2 should be passing at 2. So we set this point was 2. So that is our graph passing at 2. So the portion I'm shading must be surrounded by 1, 2, 3, 4. So this is 1, 2, 3. The y-axis is 4. So that is the portion I am shading. So this is the portion that once it is rotated about the x-axis, then we should be able to calculate the volume. So looking at that shaded portion, we now need to decide on the representative strip that we can put there. If you want to try horizontal, you will discover that horizontal is a problem because here you touch two graphs, the same two graphs, but once you reach here, one graph has changed. If you even go there, one graph has changed. So that is how I know that the horizontal strip is not an ideal, or it's not the best one here. Because a strip, you must put in your mind that should forever touch two graphs all the times. So if I go for a vertical strip, you see I'm touching the same two graphs. Whether I'm putting it to the right or at the center or to the left, it's touching the same two graphs. So this shows to me that a vertical strip should be the best option here. So I will now extend it to touch my x-axis. And once I use a vertical strip, since it's parallel to the y, it reminds me that the two graphs the strip is touching must be labeled using y. The first graph is the one passing above the strip, which is y equal to 6 plus x squared. The second graph is the one passing below the strip, which is y equal to, that will be y2 equal to 4 minus x squared. And this is my x equal to 2, which is the upper limit of integration. So I'm done with that part. Now I can go to the volume. So whenever you're calculating the volume, in case you don't know which formula to choose, start by checking your rotation. You see, the problem says x-axis rotation. So my formula will start with Vx. How does it end? Look at the strip in my diagram. If it touches the x-axis, my formula must end with dx. So as an N6 student, you then move to page 5 of your formula sheet. Check that formula that starts with Vx and ends with dx. Such a formula will be having pi there, the integral from a to b, y1 squared minus y2 squared. So that's your value. And this one is what we call the disk method because your strip is perpendicular to the axis of rotation. So that's the disk method. Then we can now start integrating. If I substitute the values a and b, which are the limits I can see on the x-axis, from 0 to 2, that's where my shaping takes place. Or if I could pick it up from the data over there, it's okay. Your formula reminds you that you must break the limit on the x-axis. So I have 0 to 2, y1, you see your y1. So our y1 is 6 plus x squared. This time we are reminded to square it. y2 is another, it's 4 minus x squared. We also reminded to square it. Then from here, you can now start opening your bracket. So for my students, I always remind you that this is an expansion you must know up by heart. If I'm expanding this, I don't have time to be doing the FOIL method. What I simply do is that I take a squared, it gives you a squared, you take b squared, you get b squared, and in the middle you take 2 times a times b. That gives you 2ab. That's how fast you can do that expansion when the power is 2. So if I apply that here, you see that 6 squared will be 36, x squared, all that square will be x to the power 4. And in the middle, I will take 2 times 6, that is 12 times 2x. It gives me 12x squared plus. Then I do the same thing here. 4 squared, 16, x squared, all that square gives you x to the power 4. Then in the middle, I take 2 times 4 is 8 times negative x squared is negative 8x squared. I put another positive. Then you see, I'm done with my expansion within the shell. I can now open the bracket. If I open the bracket, I will be getting 36 minus 16, that's 20. Then I take 12x squared minus 8x squared. That will give me another 20 because it's 12 minus minus, that becomes plus. So 20x squared, then x to the power 4 minus x to the power 4 disappears. So that's what I get. Then I integrate, I get 20x minus plus 20 over 3x squared from 0 to 2. Then I put my limit, I put 2 there, times 20 is 40. Then plus 2 squared is 4. 4 times 20 is 80 over 3. That's my upper limit. Lower limit is a 0 plus a 0. Then I talk to my calculator. So with volumes, you are allowed to leave your answer in terms of pi, so I can simply take 80 on 3 plus 40. That gives me 200 over 3 pi. So I can say that's my volume, 200 over 3 pi unit cube. If you want to multiply by pi, it's fine. So guys, thank you. That's our volume divided discussion.